In this video today, we're going to go over proving that lines are parallel using the postulates and theorems that we've already covered. So this is Unit 1, Section 6. So this warm-up here says state the converse of each statement, and to do that, all we have to do is flip the if and then statement. So if A equals B, then A plus C equals B plus C. So if A plus C equals B plus C, then A equals B. Number two, if the measure of angle A plus the measure of angle B is 90 degrees, then angle A and angle B are complementary. Again, we're going to flip it. So if angle A and angle B are complementary, then the measure of A plus B is equal to 90 degrees. Then this third one says if AB is plus BC is equal to AC, then AB and C are collinear. And this one right here, it represents the segment addition postulate, number 3. So we're going to flip it again. If AB and C are collinear, then AB plus BC equals AC. So our vocab today is I can state the converse statement formed by exchanging the hypothesis and conclusion of a conditional statement. So we've got hypothesis, we've got conclusion, we've got conditional statement, and we've got converse. Those are all things that we're going to go over today. So our objective today is to use the angles formed by a transversal to prove two lines are parallel. So the converse of a theorem is found by exchanging the hypothesis and conclusion. We already did that, and we talked about it a minute ago. The converse of a theorem is not automatically true. If it's true, it must be stated as a postulate or proved as a separate theorem. So on this first one, it's the converse or corresponding angles postulate. It says if two coplanar lines are cut by a transversal so that a pair of corresponding angles are congruent, then the two lines are parallel. So if angles 1 and 2 are congruent and they are in corresponding positions, then we can say that lines M and N are parallel. So we're going to do that right here. We're going to show that line L and line M are parallel. Right now we don't know that they're parallel. They have no parallel symbols on them, and those parallel symbols are an extra set of arrows. So the first thing this tells us is that 4 and 8 are congruent. So we're going to go ahead and mark that in the drawing, 4 and 8. Then we're going to work through this statement here. 4 and 8 are congruent. They're corresponding angles. So we can say that L is parallel to M by the converse of corresponding angles postulate. Now this is a converse because prior we learned that when the lines were parallel, 4 and 8 were in corresponding positions, thus they were congruent. This time we're saying the angles are congruent first, and then we're saying that the lines are parallel. So we can say that these lines are parallel now, so we're going to put some parallel symbols on them because the angles were congruent. So the converse of corresponding angles postulate. This one right here, what I want you guys to do first is go ahead and plug in 30 for x and solve for the angles, because this is asking us to prove again that line L is parallel to M. So when you do that, you should get 120 minus 80, which is 40 for 3, and 90, which is 3 times 30, minus 50, and that equals 40. So those two angles are congruent. So again, let's look at where they are in the drawing. We can say that 3 and 7 are congruent. So let's look again where they are in the drawing, and then let's draw this. 3 is congruent with 7 like that. So again, because those angles are congruent and they're in corresponding positions, then we can say that L is parallel to M by the converse of the corresponding angles postulate. This next one says through a point not on line L, there's exactly one line parallel to L. So that means I got a line up here, and I got a point off that line. There's really only one line that I could draw through that point that would be parallel. Then these two lines would be parallel. That's what the parallel postulate tells us. So we've got these 3 more. So we're doing the converse of the alternate interior angles theorem. And notice here again that angle 1 is congruent to angle 2. Because those angles are congruent and they're in corresponding, alternate interior angles position, we can then say that line M is parallel to N. So by the converse of the alternate interior angles theorem. On this next one down here, we can see that angle 3 is congruent with angle 4. Those are in alternate exterior angles position. So because they are in the alternate exterior position and they are congruent, we can say by the converse of the alternate exterior angles theorem, line M is parallel to N. The last one down here, it says that angle 5 plus angle 6 is 180 degrees. That means those angles are supplementary. They are in the position of same side interior angles. So we would use the converse of the same side interior angles theorem to prove that the lines were parallel because those two angles were supplementary. Example 2a. So it says use the given information to show that R is parallel to S. So we're given that 4 is congruent to 8, so we're going to go ahead and mark those in the drawing. And so when we work through this proof here, our first statement was given to us, and we were given number 2 as well, and number 2 is R is parallel to S, and again, that's because of the converse of alternate exterior angles theorem, and we can see that 4 and 8 are alternate exterior angles to each other. Again, remember that when we're proving that lines are parallel, we always use a converse. So the first word is always going to be converse when you're trying to prove that lines are parallel. So on this one, we're going to plug in the 5 for angle 2 and 3 to solve for them. And then we're going to work through this and show that R is parallel to S. So first of all, go ahead and plug in the 5. So we get 58 degrees for 1, and we get 122 degrees for 2. Then I want you to look in the picture where angles 2 and 3 are. They're right here. Angle 2 is there, and angle 3 is there, and you should know that when you add those two angles together, they equal 180 because they are same side interior angles, and same side interior angles are supplementary. So that's going to be our next step, is to see if that's true, and it is. So finally, we are going to say that R is parallel to S by the converse of same side interior angles. And again, if you need more time to write, then pause the video and then start it again to go on to the next problem. So here's our check it out 2b. Again, I would like you guys to go ahead and plug in the 50 into both the equation for the measure of angle 3 and the equation for the measure of angle 7, and then we're going to talk about that once you have done that. So for step 1, we're going to do all that in step 1 this time. And I think most of y'all can do this in your head, so you could have just pretty much told me that 2 times 50 was 100 and 50 plus 50 is 100. So you could have just told me the measure of angle 3 was 100 and the measure of angle 7 was 100 by substituting 50 in for x. Then our next step would be basically to show that those two are congruent. So again, you don't necessarily have to show me the step 2, but you do need to show me that angle 3 is congruent with angle 7, or that the measure of angle 3 is congruent with the measure of angle 7. And then when you're done with this, you're going to tell me that R is parallel to S. Again, those two angles, if you look at 3 and 7, so let's go ahead and mark them in our drawing. 3 is here and 7 is there. Those are alternate interior angles. So we're going to say the converse of alternate interior angles to prove that the angles are, or that the lines are parallel. Okay. So let's look at this one. Now I will tell you that on y'all's drawing, it already has marks on L and M, and that's not right because that's what we're actually trying to prove. So what I want you guys to do is go ahead and put some arrows on P and R. So that shows that P and R are parallel, and then we have that 1 is congruent with 3. So I'm going to go ahead and mark that on my drawing as well. So notice here, step 1, I've already got it up there. It's given to us. Now I want you guys to look at angles 1 and 2. It says, again, in our proof here that they're congruent. And so the question is, what is the reason that they are congruent? Hopefully you see that they are on the same side of the transversal and on the same side of L and M. So that would mean they're corresponding angles. So we're going to say the corresponding angles postulate. Now, step 3 for the reason says that it's given, and the only piece of given information we haven't put up there yet was this angle 1 is congruent to angle 3, so that's what we're going to do. Then I want you to look at angles 2 and 3 here. That's what our statement is here, but look prior. We've got angle 1 is congruent to angle 2, and angle 1 is congruent to angle 3. Notice here that we have the 3 angles. Do you remember me teaching you guys that R, S, T, reflexive is 1, symmetric is 2, transitive is 3. So we have 3 angles there. So this would be the transitive property of congruence. Now we can say 2 and 3 are alternate exterior angles. So we can say that L is parallel to M by the converse of the alternate exterior angles theorem. All right, let's look at this next proof. So first we're given that 1 and 4 are congruent, so we're going to go ahead and draw that. 1 is congruent to 4. It also tells us that 1 and 4 are supplementary. That means when we add them together, they equal 180. So those are just some things I'm going to mark in my drawing. And what I want you guys to do is try to work through this proof based on what you know you can already write. So hopefully you know step 1, you can get step 3, you can get step 6. You should also be able to get this step 8 down here. So step 1 was given. Now, I told my students yesterday when I taught them that if we're going from a congruence to an equal sign or from an equal sign to a congruent sign, we're always going to use this definition of congruence. And in this case, we're talking about angles. Step 3 was given information, so the only piece of information we haven't put in here yet that was given was angle 3 and angle 4 are supplementary. Now, the definition of supplementary angles, I'm going to go back here to our drawing, is this. Angle 3 plus angle 4 equals 180. So that's what we're going to write there. Now I want you guys to notice something for this next step. We have measure of angle 3 and measure of angle 3. That's the same, but 4 and 1 are different here. Do you notice up here that it tells us that the measure of angle 1 is equal to the measure of angle 4? So that means we can substitute the measure of angle 1 in for the measure of angle 4. So that's the answer there. And then the vertical angles theorem, again, let's look back at our drawing. Do you notice that 2 is congruent to 3 here because they are vertical angles? So that's what's going to go in step 6. Here again, what is the only thing that's different between 5 and 7? It's just 3 and 2. And that's because, again, 2 is congruent to 3. So we're going to then, again, substitute in the 2 for the 3. Now, I want you guys to look back at your drawing again for 2 and 1. So if we look back here at this drawing for angles 2 and 1, those are same side interior angles. So we're going to say that our reason that these two lines are parallel, L and M, are the converse of same side interior angles theorem. And again, if you need to write all this down, pause it, fill in your notes, and then you can move on. So our next example is example 4. It's a carpentry application. So on this one, again, it says show that pieces A and B are parallel. Well, again, I notice 1 and 2 here look like they're same side interior angles. So they should be supplementary. So what we want to do is plug this 15 up here in that X and plug this 15 up there in that X and see if that is the relationship that then comes forth. So that's exactly what we're going to do. We're going to substitute that in. So we get 140 for the measure of angle 1 and we get 40 for the measure of angle 2. Now when I add these two together, I actually get 180, and that's what they should be. So we can then say that pieces A and B are parallel by the converse of same side interiors because the same side interior angles were supplementary. So once again, if you need a little more time to fill in your blanks, pause the video and then come back to me for the last one. So it says, what if suppose that the corresponding angles on the opposite sides of the boat measured 4x minus 2 and 3y plus 6, where y equals 8. So we're going to plug that 8 back in to this problem. So 4 times 8 minus 2 is 30, and 3 times 8 is 24, plus 6 is also 30. So here again, we should be able to see that angle 1 is congruent with angle 2. And so that tells us then, because those are in corresponding positions, that those oars on the right side of the boat are parallel. The angles are congruent, so the oars are parallel by the converse of the corresponding angles postulate.